Hi, I'm Kritika Mishra and I'm solving the first question of the Endsem. So, question 1. It says there's a room containing 20,000 cubic feet of air, 600 cubic feet of fresh air flows in per minute, and the mixture is uniform. It's exhausted at a rate of 600 cubic feet per minute. So, the thing is that because there's a constant volume of air inside the room, uh, because it enters at 600 cubic feet per minute and it's exhausted also at the same rate. So the amount of fresh air being the amount of fresh air in the room, like the inflow rate minus the outflow rate, that would be like y dash or dy by dt. It's incoming at 600 and it's getting exhausted at 600 y by 200,000. Sorry, 20,000, because that's the volume of the room. Yeah, so this is equal to 600 minus 0.03y, which implies dy by 600 minus 0.03y is equal to dt. You can integrate this. This would give ln 600 minus 0.03y divided by minus 0.03 is equal to t plus. So there's going to be a constant, so we can just make it ln c. It'll help in like when we're dealing with this ln. And I'm going to take this over there. Now I could multiply this LNC with minus 0.03, or I can just assume that it becomes some other ln and some constant, like some different constant. Let's just call it ln k, because it's going to change this term, multiplying it with 0.03. So let's just like change it into some other term. Okay, so we can take this k over here. It will become ln 600 minus 0.03y minus ln k is equal to minus 0.03t. And yeah, because and according to the rules of log, if we want to like not have to deal with this minus sign, we can just convert this into by k, because ln a minus ln b is ln a by b. So this implies that 600 minus 0.03y is equal to k into e power minus 0.03t. Now it's given that y of 0 is equal to 0. Or okay, first let me just simplify this a little bit. So this is dividing this. So 600 by 0.03 would become 20,000. And then k by 0.03 is just some other constant. Let's go back to calling it c, or let's just call it c1, let's say. And e power minus 0.03t is equal to y. Yeah, so now y of 0 is equal to 0. This is a given. So if we put this has no t term, so it's not going to change. The only t term is over here, so e power minus 0.03 into 0 would just be e power 0, and e power 0 is 1. So that implies C1 is equal to 20,000. So overall the equation is 20,000 minus, and because C1 is 20,000, so 20,000 e power minus 0.03 t is equal to y. So yeah, this is y of t. And now we want to know after what time will y be 90%. Oh sorry, after what time will 90% of the air be fresh air. So let's just simplify this a little bit. Let's just take 20,000 outside. And in this case we want it is equal to 90%, 90 by 100 of 20,000. So I can just cancel this 20,000 here and 20,000 here, which implies 1 minus e power minus 0.03 t is equal to 0.9. 90 by 100 is 0.9. So let's just shift this around a little bit. 1 minus 0.9 is 0.1 is equal to e power minus 0.03 t. So again we can like take this over here, it will become an ln, which imply, and this is 1 by 10, right? Ln 1 by 10 is equal to minus 0.03 t, which implies minus ln 10, because by the rules of log, is equal to minus 0.03 t. So which implies t is equal to ln 10 by 0.03, and that's equal to 76.75. 76.75 is roughly equal to 77 minutes, because we were dealing with cubic feet per minute. So the equation for the amount of fresh air at any time is this 20,000 minus 20,000 e power minus 0.03 t, and at the time when the room of 20,000 cubic feet has 90% fresh air, that is at 77 minutes of the process.